So this video is going to show you how to graph a quadratic relation and draw the curve of best fit using a table of values. So let's say we didn't have a graphing calculator like this, but we wanted to try to graph a quadratic that looks like something like this. How would we do that if we only had the equation and a pencil and some graph paper? So I'm going to add a table of values over here. And basically what we need to do is pick some points and start graphing them. I'm going to make this go away. And I'm going to use the graph area to calculate my work per minute. So let's say we want to start with x equals 0 is usually a good place to start. So if we put x equals 0 into the equation, we get y equals 0 squared plus 7 times 0 plus 10. So obviously this value will then be 10. Both of these go to 0, so all we're left with is y equals 10. Let's pick x equals 2. So we'll have that y equals 2 squared plus 7 times 2 plus 10. So 2 squared is 4, 7 times 2 is 14 plus 10. So our y value will be 28. So those ones got big very quickly, so I'm going to try going the other direction. Instead of going from 0 to positive 2, I'm going to go to negative 2 now. So as you'll notice, these values are not in order. If you're trying to figure out patterns in a quadratic relation, you would definitely have to make sure that they're in order. But for now, just for graphing purposes, I'm just picking a few numbers and seeing what happens. So y equals negative 2 squared plus 7 times negative 2 plus 10. So that equals 4 minus 14 plus 10. So that equals 0. So we found our y-intercept at negative 2, 0. Now, how can I add these? 0, 8, negative 2, 0. Okay, I'm going to erase my writing here and add these values in. So we had 0, 10, 2, 28, negative 2, 0. Let's do a few more so we get a few more points on this graph. So let's say x equals negative 4. So y will equal negative 4 squared plus 7 times negative 4 plus 10. That will be 16 minus 28 plus 10. 16 and 10 is 26 and negative 2. Negative 2. So let's see what this looks like on a graph. That was negative 4, negative 2. So, we zoom out a little bit. Here's our point so far. We have a curve that looks a little bit like this. So we may have found our vertex based on these ones being close together. But I'm going to do another couple of values to see whether it continues going down before it goes up or whether it goes up like this. Right now, we're not sure. So let's pick negative 6. The values that are 2 apart from each other seem to be working so far for me. So negative 6, y equals negative 6 squared plus 7 times negative 6 plus 10. So that's 36 minus 42 plus 10. That would give us negative 6. Nope. Hold on. 36, 46. Nope, negative 4, sorry. No, not negative 4. Positive 4. Goodness. Okay. 36 and 10 is 46. Minus 42 is positive 4. Alright. And as you notice, we've been going up. Negative 6 and 4. So I'm going to do one more. I'm going to go with negative 8 and see what happens. Y equals negative 8 squared plus 7 times negative 8 plus 10. So we get 64 minus 48. 48? No, that's not right. 56. Goodness. It's too early in the morning for this. 56 plus 10. 74, 56. 18. Okay. Negative 8, 18. Add these values here. And now if you're graphing this by hand, you would obviously be plotting these points yourself, and you would have to figure out a good scale. Whoops, I messed something up, didn't I? Oh no. Okay. So this works. So I just double checked by adding the red line back in. So our vertex is somewhere in between these 2 points. I thought I'd mess something up because it looked like it was coming down like this. And then I messed up. But no, that totally works. So there's our line of best fit for these points. And of course these go on and on to infinity. Here's our vertex down here. Our axis of symmetry is somewhere around here. What else? Our y-intercept was at 10. Okay, so that's how you do that. Sorry. Yeah, so it'll look like this. So the next thing I wanted to talk about was if we took, I'm not sure if I can do that on this, let's see, if we put these all in order, I'm going to rearrange, so I guess just a couple need to move here. I'm going to put them in order so we can look at our values and first differences. There's 28, I believe. Okay, so there's our values, and there's our graph. Now, you remember when we've done linear equations, we've talked about the first differences. So you take the two values and you subtract them to see what the difference is between them. So since these are all in order, they're all spaced 2 x values apart, we can compare these. So for each one, we're going down 2 or negative 2, negative 2, negative 2, because 4 minus negative 2 is negative 2. So we're going down 2 every time. Now the y values, what's happening here? If we have 10 and we subtract 28, we get negative 18. 0 minus 10 is negative 10. Negative 2 minus 0 is negative 2. Now this one's a little different. 4 minus negative 2 is 6, because it's 4 minus negative 2, so it would be 4 plus 2. 18 minus 4 is 14. So obviously we don't have a linear equation here because our first differences are definitely not all the same. They are for the x values because I picked some that were all 2 units apart, but the y values are not linear, obviously. So what we can do now is figure out the second differences, and what that means is that you take these first difference values, I'm going to write FD for first differences and add this like another column to our table. And now I'm going to figure out the second differences. So I'm going to take these two values and subtract them. So negative 10 minus negative 18, so that'll be negative 10 plus 18, so that'll give me a value of 8. Negative 2 minus negative 10 will give me a value of 8. 6 minus negative 2 will be 8, and 14 minus 6 will also be 8. So now you'll notice that the second differences of our y values of our quadratic equation are all the same. And that is how you would check if you've done this correctly and if you have the right points. And that's one way of knowing that you have an actual parabola rather than a curve that just kind of looks like a parabola. But in some cases, you'll have a curve that ends up doing something weird at the top, maybe like that, instead of going straight up. In this case, we don't have that. All our first differences are 8, all our second differences are 8. So we have a quadratic equation.